All right, this one is set up for us in a little bit of a weird way, this inequality. So first thing we need to figure out is, are we going to be graphing this with a dotted line or with a solid line? A dotted line. If it does not have a line underneath like this, we do not draw a line. If it's a less than or greater than, we need to do a dotted dash, I don't care how you call it, but a dotted line. And that line that we need to graph is going to be our negative 3y equals 6x minus 9. And especially when it's not set up for us in our slope-intercept form or set up in our easy to do xy intercepts form, it's a lot of times easier to put it as our equal sign and then solve it around. Then we don't have to pay attention to which direction inequalities are facing. So this, I think, is easier to deal with than the inequality one. It just means we go back to our inequality when we're testing points. So if I want to put this into slope-intercept form, what do I need to do here? How do I get this into slope-intercept form? Yeah, that's exactly right. I need to get this negative 3 away from my y. So I'm going to divide this piece by negative 3. That's going to let those two pieces cancel out. But if I divide the left side by negative 3, I need to divide the right side. Because I can do whatever I want as long as I do the same thing to both sides. So I need to divide this guy by negative 3. And I need to divide this guy by negative 3. When we do that, we're going to get our y equals 6 divided by negative 3. Gives us a negative 2x. Minus 9 divided by negative 3 gives us a plus 3. So this is the line we're going to graph. So if we didn't get that far, graph that line real quick. Okay. So where do I put my first point using this line? Where am I going to start? Positive 3. Good. On my y-axis, it is always this guy where we start with our y-intercepts. This guy's my y-intercept. We're at positive 3. How do I move? How do I get my next point? Down 2, right 1 is 100% correct. So we use our minus 2 slope to go down 2, right 1. It's going to give us a dot right here. We're going to go down 2, right 1. Gives us a dot right here. I can keep going. Down 2, right 1. Down 2, right 1. I could go the other direction too. I could go up 2, left 1. That still keeps me on my same line. It's up here. What's up? So we look at our slope for our m here, and we always kind of default our rise over run is default state up and right. If we have a negative, we change 1. So we either go down into the right, or we go up into the left, because
do you always go right?
the default state is always 1. Or it's always right 1. If it's like a fraction and it said like 2 over 3, then it would be 2 up, 3 right. So the default state is up and right, because that's the direction of positive numbers, is the easy way to remember that. So positive numbers are up here, positive numbers are right. So we're chasing the positives. All right, so that gives us our line that we're going to connect up with a dotted line. So make sure we're being careful on that, because it should look like this. We've got our dotted line. Then we need to figure out where we're going to shade. So we get to pick absolutely any point we want to. There's some that are easier to work with than others, but we can use any point in the whole universe. We just want to know which side of our line it's on. Easiest option is to think about 0, 0. You don't have to use 0, 0, but it's an easy one to use. If we think about our 0, 0, thank you, dear. We're going to test that, but we're testing it in our original inequality. So we're going to have our minus 3 times 0, because that's our y value. And we want to know if that's going to be less than 6 times our x value of 0 minus 9. We want to know if this is going to be true or not. So negative 3 times 0 is what? 0. And we want to know if that's less than 6 times 0, which, oh, times 0 again, that's another 0. Hello, blinky screen. Okay, 0 minus 9. Well, is 0 less than negative 9? No. So is this in my colored in area? No. This is not a solution, so this is not in my colorful area, which means I need to color that aside. So our shaded region on this one is above the line. It's up here. And you do not have to make it perfect. It's okay if it's a little scribbly. It's okay if it's a lot scribbly. If you do this, I understand what you mean. I'm a little bit of a perfectionist, so I like it. I like it mostly covered. But that's just for me. Okay. Questions on that one? Because I know it's been a couple of days and they're weird. Okay. Number 2, we're not graphing. We're just finding our x and y intercepts. So we're looking at this 5x plus 9. I'm going to change the view real quick just so we don't have to look at the whole thing. Our 5x plus 9y equals 27. We're going to find our x-intercept. We want to find our y-intercept. How can I find those? Because we know something about each of these points. What makes it an x-intercept? What do we know about an x-intercept? Y is 0. Y has to be 0. Y must be 0. What makes it an intercept? So if I know that y is 0, when I'm trying to find my x-intercept, that means I know this guy's 0. You hush your face. Oops. That was dramatic. That was funky. Okay, there we go. All right. If I know y is 0, that means this whole thing's going to be 0, because 9 times 0 is 0. So if y is 0, this guy goes away, and we're left with just our 5x equals 27. So it's kind of the short way to think about it. If we have y is 0, our 5x has to equal 27. So how can I figure out what x is going to be? How do I get down to an x equals? Divide both sides. And we're going to divide both sides by 5. So we're going to have 27 divided by 5, which is admittedly unpleasant. But we have tools. We can divide 27 by 5. And you can have it as a fraction, which doesn't simplify. Or we can put it as a decimal, which would be easier to graph. And that's going to be about 5.4. So our x-intercept is about 5.5, or 5.4, comma 0. We get to do the same thing with the y-intercepts, except with y-intercepts, what do I know? X is going to be 0. Same kind of vibe, we just start from scratch. So this time I know that x has to be 0. So if I substitute in 0 for my x, this is going to be 5 times 0, which goes away. And we're left with just our positive 9y equals 27. So if we look at 9y equals 27, what do I do to get y by itself? Divide by 9. What is 27 divided by 9? 3. So our y-intercept would happen at 0, 3. So we use that a lot of times when we're graphing in this standard form. That's what that's called when they look like that. Our x's and y's are together. But it's not a huge deal. Okay. Questions on either of these? Okay. Because we are going to keep working with our piecewise functions, but we're going to work with a special kind of piecewise function. So our special functions are getting a little more special because it's a very, very specific kind of piecewise function, which is called a stepwise function. And this is on page 6. It looks like this. Yes, dear. Yeah, let me your best. I just like to double check because I'm still at the point where I'm going. All right. So a stepwise function is a very, very special kind of a piecewise function. So we're going to write this little definition right at the top. And it just says it's a piecewise function. So just like the ones from yesterday where we're going to have little bitty chunks all over the place, using only horizontal lines. I can never remember if it's an S or a Z. Z. So yesterday when we were looking at piecewise functions, we had lines and we had little horizontal lines. We could have more pieces and we had stuff like this. That is a piecewise function. It's made up of separate pieces. When we're thinking about stepwise functions, specifically, it has to use horizontal lines. More often than not, they're in order. They don't have to be. You could have little pieces down here and up here. But it's made up of, essentially, it looks like a Mario level. Please do. Oh, page 6. It should be at the top of page 6. Sorry, I'll put that up here. So if it kind of looks like a Mario level, we are probably stepwise. Mario does very little ramps. So it's only going to be made of horizontal pieces because it kind of looks like floating stairs. Yeah, we have to do some jumps here, but it's all horizontal lines. So stepwise functions are just made up of horizontal pieces. And we actually interact with these quite a bit in the real world. We're just not used to thinking of them like this because this is how things like paying for parking at Circle Center, paying for parking in any kind of parking garage, or prices of stamps, that kind of stuff are all done as a stepwise function. So we're going to look at a couple of those to start with before we get into kind of the abstractiness. So we're actually starting with everyone's most favoriteest thing, a story problem. And this is one of those actual, factual, real-world situations where these are used. Because this is how stamps are priced in the Postal Service right now. So the cost of mailing a letter is determined by the weight of the letter. But there's wiggle room because not every letter is the same amount. If I use 2 pieces of paper versus 5 pieces of paper, they don't want to have to charge those separately because that's a lot of work. So up to a certain amount of weight, which is up to 1 ounce, for not over 1 ounce, it's 47 cents. So if I have an empty envelope up to a 1 ounce envelope, it's going to cost me 47 cents, which is usually one of those little forever stamps. If it's between 1 ounce and 2 ounces, it's an additional stamp. 2 ounces and 3 ounces, I need more. 3 ounces to $3.54, which seems arbitrary, is a different price. And at that point is when they decide that it's technically a package, and you have to go with like the box prices. So it's taken this information in this paragraph that's saying all these same things. I don't know why I highlighted the year. That was a silly choice. But we have 47 cents for letters not over 1 ounce, meaning if I have an empty envelope that I mail all the way up to 1 ounce envelope, it costs 47 cents. So if I send nothing, or if I get all the way up to 1 ounce, it's going to cost me 47 cents. So if I want to draw that on my graph, just that little piece, going from 0 to 1 ounce is going to cost me 47 cents. Well, if we look at how this graph is counting, it's counting by 0.4 every 2 lines, instead of 0.2 each line, because they do weird things when they're counting here. So 47 is going to be right about in here. Since they have an equals to on the 1, my 1 ounce envelope also costs 47 cents. I'm going to put a dot right there. What would it cost for me to send something that weighs nothing? There is no weight, no mass. Am I actually sending something if there is no weight to it? Sending you my wishes and dreams. How much does it cost to mail that? Are they going to charge me to send you my wishes and dreams? I'm doing it right now. Look, I mailed it to you. I mailed it to you. Does it cost me anything? Because does it weigh anything? So, 0. It's not going to charge us a dang on thing to mail nothing. It's imaginary. I mail you all the imaginary money. It doesn't cost us nothing. So not going to charge me for mailing air. I mean, canned air, like then we can get all kinds of weird bougie stuff. But don't charge me for mailing nothing. It's wishes and dreams. So we just take these in pieces. So anything from a non-empty envelope, or actually an empty envelope, just not empty air, up to 1 ounce, costs the same amount. Then as soon as we get to that 1.01 ounces, just the smidge above 1, they're like, nope, next price. It's got to go up. Now you're doing too much. So once we get to, if it's not over 2 ounces, so more than 1 but not more than 2, it's going to cost 68 cents. So not 1, but really close to 1, so like 0.1 or 1.1 or 1.001, super duper close. It's going to be up at 68 cents. So it's going to jump up a bit. But the way we say it's as close to 1 as possible without actually equaling 1 is when we put that open circle. So we're going to have this open circle on the 1 at about our 68 cents. And that goes from 1 ounce up to 2 ounces. I plop my envelope on the scale and it says 2.00. They are charging me the exact same amount as if it said 1.0001. Our next one that they're giving us is that it's 0.89 if it's not over 3 ounces, so the very same vibe, starting from 2.000001. Smidge over 2, all the way up until 3. It's going to charge us 89 cents. So 89 cents, that's almost 90 cents, that's right about here. And again, I can go all the way to 2, but I cannot equal 2. It could be 2.000001. So the way we mark that is we just put that open circle, that hole, it's a gap. It's saying, hey, I can get real close. I can be the obnoxious little sibling and go, and then continue, and then continue, and then continue. I'm just really, really close. That's what the open circle says is neener, neener. But we can go from our 2 ounces all the way up to 3 ounces at this 89 cents. And that's a flat rate between them. It's like those flat rate shipping boxes. It doesn't matter what I put in there, as long as it fits in there, we're good. And then our last little argumentative piece here. One more section. Make sure I need to do a different color. Let's do that one. And we got 110 if it's not over 3.54 ounces. So 3.5-ish ounces. So at that point, they make you call it a package, and they stop letting you use stamps. So looking at our, where are we at? 110. We have that in the table too, just so we're clear. So our 110 is going to be around here. But we don't go all the way up to 4 ounces. This one goes to about 3.5, maybe a little more than 3.5, 3.54. So this one's going to be a little bit shorter of a piece. It's not going to go all the way over to 4. Right here is where it switches. I don't know why they chose 3.54. I'm sure there's some sort of logic behind it. I just don't know what it is. So it works very much like a piecewise function. It's still separate little pieces. But because they're all straight horizontal lines, that's what makes this a stepwise function. I could take a little guy and just go hop, 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 hop across it, and he would not roll off. We're going to talk domain and range on this one because they look a little weird. It's not going to be something we have to do tons of. Our domain is 100% going to be exactly what these restrictions are. We go from 0 to 1, 1 to 2, 2 to 3, 3 to 3.54. Did I miss anything in between? No, I have values for everything from my nigh empty envelope all the way up to where they say, okay, this is not a letter anymore. This is clearly a box. So our domain is going to be everything from our 0 up to that 3.54. You can put that as an interval like this. And technically it would have a parentheses. Again, I don't really care about your brackets versus parentheses. If we get the numbers, we're good. And again, not going to be something we have to do a lot with these stepwise or piecewise functions because they're gross. So our domain restrictions actually tell us our domain. This is going from 0 to 3.54. What are our y values? What is our range going to be? I'm going to say, if we know we have our 47 cents, do I ever get charged 50 cents for a letter? No. It's 47 cents or it's 68 cents. It jumps between. Kind of like if I park at the mall for 2 hours versus if I park at the mall for 4 hours. I'm never being charged in between here. So it's just our 47 cents, and then our 68 cents, and then our 89 cents, and then our $1.10. It's those 4 numbers. So it's very much like when we had those discrete, where we just had our polka dots. This is not a discrete function, but it is very similar range-wise. Where if I'm teleporting from place to place, it would just be a list. So our range would be our 47 cents and our 68 cents and our 89 cents and our $1.10. If we're getting pedantic about it, you put them in squiggly brackets. Genuinely, if you just make the list, I would 100% be okay with that. I don't know that we ever asked you to on the homework because doing it with piecewise and stepwise functions is objectively gross. Just flipping all the way back to where I have the homeworks. Gotta double check that. Yeah, no, we don't have any time where I think we ask you to do that. So we should be okay. Just wanting us to see it and practice it, but it's not something we're going to be asked to do on a super regular basis. Oh, I did the other homework keys, but then I just didn't put them away properly. Fun times. Okay. So we're good. Okay. Questions on this one? They're weird, and we're going to practice this a little bit more. We've got the one at the bottom. Very similar vibe. This one is set up just like our piecewise function, where we have our f of x. Remember, this guy is just y wearing a cheesy mustache. We've got our domain restrictions over here. So this is telling us, okay, my y is going to equal -2, but only for this part. My y is going to equal 4, but only for this guy. My y is going to equal 1, but only when x is bigger than or equal to 4. So we're going to do these in chunks, in pieces. For this guy, if y equals -2, because that's what that says to me, y equals -2, that's a horizontal line. Sometimes it's over there. Fine. Oh. I just fine. So if y equals -2, that's down here, where my y equals -2. But if it only happens when x is less than or equal to 0, it means I'm going to start at 0, and I need to go less than. So this line is going to go that way. My x can be smaller than or equal to 0. So at -2, on our y, we're going to have a dot. And if my x's are smaller than 0, we're going to go this way. There should be rulers sticking up out of the cups on the tables for a lot of them. So your line should look like this. And this continues onwards down into the negatives because my x is smaller than 0. It's not cutting it off at any point. If we look at my y equals 4 here, y equals 4, but only when x is between 1 and 3, y equals 4 happens up here. This guy. If I wanted to draw the whole line, it would be this whole thing over here. All the way across. But it's not the whole line, because it would no longer be a function. And we need it to stay a function. So we got to only go between 1 and 3. So it's just going to be this little piece of it that goes right here. On 4, between 1 and 3. So 1, 4, and 3, 4. And you can make table for this if you prefer to do it with a table like exactly how we did it with the piecewise functions, where you make a dot for your starting point and a dot for your end point and fill it in. Totally valid. It works 100% the same way. There's a lot of times we'll get thrown off by the fact that these are just horizontal lines if I just gave it to you as a piecewise and we didn't talk about it. And then our last one up here, our last piece talks about when our y is 1, if our x is bigger than 4. So this equation is y equals 1. Well, y equals 1 is right here. That's where my y is stuck at 1. It can't go up, it can't go down, it's stuck at 1. So it looks like this. But again, it's not my whole line, or it's not a function here, it's not a function here. I need it to be a function still. So it's only when my x is greater than 4. So we start at 4 and we go bigger. And if it works better for your brain to draw the whole line and then erase down, that's totally valid. You can absolutely do that. It just makes it very difficult sometimes to read, and my digital lines don't do that super well. So I prefer to do that, just drawing it in the chunks. We are not doing domain and range on this one. But we are going to look at the top of the next page, because I want us to try the next thing we have in here. Okay. Any questions on this one or the one we did previously? Because it's going to feel like a slight shift. Because now what we're going to do is we're going to look at graphs. So this is at the top of page 7. And first thing we're given is this graph, and we're asked to say what kind of function it is. Is this a linear function? Is this a piecewise function, or is this a stepwise function? Those are kind of the only ones we've worked with so far. What do we think? Is this a linear function? Is this made up of a single line? So not linear, definitely know that. Less. Is this a stepwise function where it's only made of our horizontal lines, like the one we just did? I've got a slant in here. This guy right here means we are not stepwise. If Mario hopped on this little stick, he would fall down into the pit. That's Yoshi, but still. I can't just hop from one piece to the other. So this is a piecewise function, is what we call this. It's cut into pieces, and they are not just horizontal lines. This is a piecewise function. And what we're going to do is we're going to try and name what these pieces are. They've given us some of them. They've told us that one of these segments is going to be at our y equals minus 4. Well, I see y equals minus 4, and that's this guy right here. So we want to see if we can figure out what the heck they picked for their x's. What was their rule for x's that we can fill in for this blank? What do we know about the x's for this purple section here? I'm going to zoom it in still so we can see clearer. What do we know about the x's? What is the biggest x we have on this piece? What is the smallest x we have on this piece? What is the biggest x on this piece? What's the biggest x here? -2. Because on this purple section, it's everything, it's -2 and smaller. So my x's for that purple section here needs to be smaller than our -2. So we can say x needs to be less than or equal to -2. So we're kind of trying to write our own portions of the equations. I'm going to block it back out again. So the next one I'm going to look at is this guy here. They give us the equation. They say it's minus 3x. And we could look at that in tech. We could count our slope. We could figure out our y-intercept. We could write that equation. We can do those things. What rule does our x need to follow here? We want to write a rule for our x's. What do we know about the x's for this green chunk? What's the smallest it can be? What's the biggest it can be? What's the smallest the x can be on this green chunk? I'm stuck. I'm just bouncing back and forth on this line. Where? 0 is the smallest it can be. What's the biggest it can be? 2. Oop, pen. So we know that our x needs to be at least bigger than 0 and smaller than 2. Are we going to use the equal sign, like on the first one, or are we going to not use the equal sign? This is a little hard to see when it's zoomed out. I'm zooming it in real fast. The line looks like this. Are we going to include the points? Look at these pieces. Are we doing an equals to or are we doing a not equals to? Not equals to. If we have an open circle, that's, I can get super obnoxiously close to it and go, I'm not touching you, I'm not touching you, I'm not touching you. But 0.00001, totally fine. 0.00001, totally fine. I just can't touch 0. Same thing with the 2. If we have these open circles, there we go. This one's open. This one was closed. That's why we had the equals. If we have an open circle, we do not put the equals to under here. If we have a closed circle, we do. Let's see what we can come up with for the last one. One more section of this one. We've got this little guy right here. Now this time they don't give us anything. So what would our y equals for this little blue piece be? What will y equal? 2. It's right on that 2. It's not a slope. We don't need to find an angle for it. It's just at 2. What do we know about our x's for this blue piece? What's the smallest it can be? Yeah, like 5. It's between the 4 and the 6. And if you say it's 4.5, totally fine. You say it's 6.5, well, 6.5 wouldn't work, but 5.5, totally fine. If we're guessing, totally fine. We know it's going to be something to do with 5. Does my x need to be bigger than or smaller than 5? Bigger. Can it be equals to 5? No, because of that open circle. So if we have an open circle, all 3 of these ones were open, that's when we do not have the equals to underneath. Okay? We will look at number 2 tomorrow before we start talking about some absolute values. We'll practice it again because it's a really good thing for us to practice. These are on homework 1.5. It is not a different homework. It's the same one I gave you guys yesterday. Says it's listed as Thursday. It is definitely not due tomorrow because there's stuff on there we have not talked about. Yes, dear. Let me grab you a copy of it real quick. Hang on just a second. I'm saying at the earliest, Friday. We will see how it goes tomorrow as to if we get as far as we need to. Because there's just things on there that we have not talked about yet, and it's not fair for me to have homework due on things we haven't talked about yet. Let me get our announcements pulled up.
This is the homework from this one, right?
Yep, that's the one. That's the one. Go here.